Okay, so I'm going to go through the homework problems. Problem number 1, find the equation of perpendicular bisector of this line segment. So I'm going to do the midpoint first. The midpoint. So x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So the midpoint is negative 2 over 2 and 4 over 2. Simplify that to negative 1 and 2. And then the slope, so slope of AB, so the x coordinates go on the bottom, negative 5 minus 3, and y coordinates go on the top, so negative 8 over negative 8, which equals 1. You could also do the other way around. You can do 6 minus negative 2, which is 6 plus 2, 3 minus negative 5, which is 3 plus 5, and get 8 over 8. So the slope equals 1. So then that's the slope of the segment, but I need the slope of the perpendicular would be the opposite reciprocal, so this would just be negative 1. Okay, so now I plug into my equation, y equals mx plus c. So y is 2, slope is negative 1, x is negative 1 plus c, so I get 2 equals 1 plus c, so c has to be 1. So my equation would be y equals negative x plus 1. Okay. Problem 2, same thing, only we've got a different one. So just do the same exact thing. Negative 5 plus 2 over 2 and 0 minus 3 over 2. So this is going to be negative 3 over 2. I'm going to write that as negative 1.5. And this is negative 3 over 2. So negative 1.5. Double check that. Okay, so now, the slope of xy equals, I'm going to do y's on the top. 0 minus negative 3 is 0 plus 3, and negative 5 minus 2. So we get 3 over negative 7. Okay, but then the slope of the perpendicular would be opposite reciprocal, so positive 7/3. Okay, now we plug in y is negative 1.5 equals to the slope times the x plus c. And now I'm going to bust out my calculator. 7/3 times negative 1.5 is negative 3.5. And then add 3.5 to both sides. So this is equal to 2. Okay, so then our equation is y equals 7/3 x plus 2. Okay, and then circumcenter, you only have to do 2 of these. So you could have all done it in many different ways. And I'm just going to use GeoGebra to check this. So let me open up GeoGebra geometry, and let's show the grid and the axes. So now I can do negative 7 and 1. So negative 7 and 1. And then negative 1, negative 2. Negative 1, negative 2. And 5 and 1. 5 and 1. So I'm going to make a triangle out of these. And the circumcenter is going to be the intersection of the perpendicular bisectors. And so it doesn't matter if I do all 3 or just 2, because they're all going to be at the same spot. So the coordinates of this point should be negative 1 and 5.5. Let's just make sure GeoGebra isn't rounding. That's to 5 decimal places, so this should be exact. Negative 1, 5.5. And we can see it's outside the triangle, so that was that. The answer to this is the circumcenter inside or outside. So how could we answer this without looking at the triangle? This turns out to be only the case when it's an obtuse triangle, meaning one of the angles is greater than 180. So if that's the case, the circumcenter will always be outside. If it's an acute triangle, meaning all angles are less than 90, then it will be inside the triangle. And if it's a right triangle, then it will actually be, here I can move these around and kind of show you. Here's an acute triangle where it goes inside. If I make it a right triangle, let's try to make, it'll be on the segment right on the midpoint of the side across from the right angle. If I make this exactly 90 degrees. So I'm going to have to measure. I'm going to have to measure this angle to get it to be 90. So that's a 98. So I'm going to have to move it. There we go. So it's right there across from the right angle. So that's 3 cases. Inside, outside for obtuse, like the one we had, or right on the 90 degree angle, which is really hard to get it there. I don't know how I did that the first time. It's hard. But it should be right on the segment. Okay. So I'm not going to go through the actual equations for that one, but you can just know your answer should have been, now I forget, negative 1 and 5.5.